TEJ, we're going to be looking at analog output. So there's a way of varying the amount of output. It doesn't have to be just all on or all off. That's what we've seen so far with LEDs. But there's a way to make it look like the light is at a lower intensity, for example, with an LED. And there's also, this is also a way of making motors turn at a faster, slower rate. And it's something called the duty cycle. So if it's always off, you can see very clearly the line shows 0 voltage. Now this goes all the way up to 255 in our case. And 255 is always on, so you can see the line shows that it's always on. In the middle of that, we have 127, half on and half off. So what the effect is if we blink the light, the LED on and off rapidly enough, our eyes will not be able to see the light going on and off. We'll just see that. We'll see that. What's the name? The word I'm looking for. The word I was looking for was perceive. So our eyes will perceive that as a lower intensity. As you can see, 64. So we're going to talk about duty cycle. Duty cycle is when it's on. Okay, 0 is always off. Okay, so the duty cycle with 64. Well, the on cycle is at a low, smaller interval, and the off cycle is a larger interval. 192, on the other hand, the on cycle is at a larger interval. So you get the idea. So in this way, we can encode any number between 0 and 255 using a pulse and any intensity of LED that we want. So this can be useful, and especially when we get into motors, because we're working with the simulator, anything that you learn here can be applied to a motor. We may not get to motors just because it is mostly digital. But let's go to our circuit here, and I am going to create a new one. That was our last one. So new circuit, and we'll call it analog write with LED. And we'll want to get an Arduino and also a breadboard. Small breadboard is fine. So we need an LED. We'll need a resistor. And the resistor, I'm going to put it in the longer leg there. So we want the value, the voltage coming from, because this is writing, it will be coming from the pin. So we're going to use pins, just a digital pin. So pin 6, and I'm going to make that go to the positive bus. And then ground can go to the other end. So this, my mistake. That one's ground. Positive bus is there. So it's coming from the positive, from the output. And we can, this is pulse, see the twiddle or the wavy line means that it is capable of PWM or pulse width modulation. So when you're doing this, you do want to make sure that you use an input that has that twiddle or that wavy line for pulse width modulation on it. So pin 6 is fine. So let's see, it comes out of pulse width modulation from 6 through the positive bus, goes through the resistor, through the longer leg or the anode of the LED, back down through ground. So we're good. We can clean this up a bit. So we're ready to program now. Let's see. Drag that over here so we can still see it when we have our code window open. And really, for our resistor, 220 ohms is good enough. That's a standard thing for an LED. So 220 ohms. I want you to notice that as you're changing the number, the bands, the colored bands change. And if you're in TEJ4M, at this point you're already aware of those bands and you've done the translation before. In grade 11, if you may not have done that, but we will be doing it if we haven't yet in the course. Okay, so let's go to our code. We're going to change it from blocks to text. And we'll erase most of the stuff that's there. Well, we can use pin mode. Leave pin mode in, and it's still going to be for output, but we don't want to use digital write. We're going to be using analog write. So we can get rid of everything in the loop. But in the setup, we'll be using pin 6 there. So pin 6 for output. And that's the only thing we need in this setup. But we're going to have a loop. And in the loop, first let's just, let's see what we can do here. We're going to make the LED look like it's changing its intensity. And luckily for us, there's a command called analog write. So we don't have to worry about the duty cycle or the pulse width modulation and what you saw over here. With you don't have to encode the individual bumps here. You just give the number, a number from 0 to 255, and that does it. So we're going to say, let's say analog write, W, capital W for write, and then our pin is pin 6. Let's just step back a second and make an integer for our pin. So I'm going to say LED pin equals 6, because then we can say LED pin, and if we change the pin, we just change the number at the top. LED pin is going to be set to, well, let's try 255 at the beginning and see what it does. So when we start a simulation, and it looks like I had a small problem with my board. This wasn't making contact. So remember that there's a bridge in the middle here where nothing gets through. So this wire here has to go extended. I'll color that wire orange just to show that's the wire. I had a mistake on that. So now when we look at our code and we start it, you can see that it shows 255 as the intensity. If I change this to, let's say, 120, you should notice that it's a bit dimmer. And it might be hard to see, but what if I put 50, then you'd probably really see it. And what if I did like 10? With the real LED, you would see it even more. But let's now add something called a for loop. And if you've taken the ICS4U class, you've seen a for loop just like this. You might have seen this if you were in the grade 11 TEJ4M class last year, but if you weren't, then we have for. So a for loop allows us to repeat things many times. I know we already have a loop, so you're probably saying, why would we want to repeat it? What we're going to do is, instead of the intensity being hard-coded here, we're going to use a variable. I'm going to use a variable I here, and I want to go through all the numbers from 0 to 255 in my loop. So, well, here's one way to do it without a for loop. We could have int I equals 0. And then we could say I equals I plus 1. And if you started, it would start low, and then it would slowly get brighter. It's probably a good idea to have a delay here. So we're going to have a delay, 10 milliseconds. I don't know if that'll be enough. So now you can kind of see it gradually getting brighter. What if we did 100? Now you can, it is getting brighter slowly but surely. Well, once it gets up to 255, it stops. It doesn't get darker again. So there's a better way of doing this. And by the way, I equals I plus 1 can be shortened to I plus plus. But there's a better way to do this. I'm going to erase that line and erase this line at the top and embed everything in something called a for loop. So it's a loop. It is a loop inside a loop. So we're going to say for int I equals 0. So I is our variable that we will be counting up by. I is going to start at 0, and we're going to continue to loop while I is less than 255. And then we're going to say increment I by 1 at the end of each loop. Put a curly brace in there, and then put a curly brace at the end. So this code will now run through these lines. When I is 0, then it'll do it for I is 1, then I is 2, all the way up to I is 254. When it reaches 255 for I, it breaks. So you should see the same sort of thing here where the LED is getting brighter. I'm going to maybe change it to 10. So we can fade in that way, and then fading out, we would do the opposite. So I'm going to copy all of this code. Notice the curly braces match up, but I'm going to copy it, paste it again, and instead of starting at 0, we'll start at 255. And we're going to, so the first part was fading out in, now this one's going to be fading out. We have to say I is greater than 0, and I minus minus. So I'm just going to put a comment here, fading in, and then this is fading out. But because it's in a loop, it'll fade in, it'll do all the for loop for fading in, then the for loop for fading out, then it'll go back to the top and do fading in and out again. So you should see it going in and out, getting higher and lower as it goes. And it kind of looks like, not quite a heartbeat, but something that may be kind of like almost like a breathing effect, where it's going in and out gradually. And that's the whole analog thing. So it's making it look like it's an analog input. In reality, you saw how this is actually happening, where it's either 0 or 1, but the duty cycle changes. So this is kind of like a way to simulate it. And that's what happens on the real Arduino as well. So that's it for this lesson on how to analog input. No, that's analog output. This was analog output, analog write. Analog input was the previous video. Bye for now.